resistances, right? So how many different types of connections or combinations of resistances we can establish while designing in circuit? We'll discuss about those two types of combinations. So mainly there are two types of combinations. First we say it is a series combination. Series combination, also known as, another name is the cascade connection or cascade combination. Series combination or cascade connection. So in series combination, one resistance is connected one after the other in a cascade manner. This is known as a cascade manner or series manner, right? So suppose this is resistance 1, this is resistance 2. We say resistance 1 and 2 are connected in series. And we can connect these two resistances by connected to a battery, and the battery is having a voltage supply of V volt. Then the current will be flowing from the positive terminal of the battery to the negative terminal. So the direction of the current will be like this. So suppose I current flows. Now the same I current also flows through this R1, and also the same I current flows through this R2. So what remains the same? Constant factor that in series connection, that the current remains the same. I remains the same for all the resistances connected in series. Okay. Now the second type of combination is your second type is known as your parallel combination. So parallel combination. Sometimes we say the parallel combination to be a shunt connection. That is cascade connection, series, one after the another, and parallel combination we say it is shunt connection. Now what is shunt? Now if I connect one resistance above another resistance in this manner, one above the other, this is one after the other, series, this is one above the other, parallel. So suppose this is your R1 and this is R2. Then we say these two resistances are connected in parallel. Okay? Now if I connect these two resistances by a EMF source or battery source providing a voltage of V, this is the positive terminal, this is negative terminal, so current flows from higher terminal to the lower terminal, here plus to minus, here the current comes. Now here the current will be divided into these two paths. There are two paths, right? So one path is belonging to R1, the other path is belonging to R2. So if I say the current I1 is flowing through R1 and I2 is flowing through R2, so what is getting divided? The current is getting divided. Here the current is not the same, right? So what is different? Here current is not equal to same. That is current is divided. So what is same? You can see this point. This point and this point are the common points of resistance R1 and also of R2. And between these 2 points, let us say name it as A and B. Between these 2 points, we are also connecting our battery supply. You can see this. So the battery supply voltage is common to R2 and common to R1. So what is the voltage drop across R1 and R2? Same. So voltage across R1 is same as voltage across R2. So these are same voltage. So V. So what is constant in parallel combination? V is constant. So what is the idea? The concept is in series combination the current remains same, the voltage gets distributed. So you can write here voltage gets distributed. That is voltage at different resistances will be different, right? Current remains same. In parallel combination, what remains same? The current is distributed. Current is not equal to same as, that is you can say this is current is distributed. The potential difference or the voltage across every individual connected in parallel remains same. That is constant. Clear? Now the second part is, now you know the idea about the combination, how they are connected. Now the second part is how to find out the total resistances, resistance formula in case of series and parallel. So you see in series combination, So what is divided? Now voltage is divided. What remains the same? Current is same. So you can write V, the supply voltage, is equal to voltage 1, that is voltage across R1, plus voltage 2, that is voltage across R2. Right? Now what is this V? The total voltage supplied to the circuit. So from Ohm's law we can write this is the product of total current of this circuit into total resistance of the circuit, which we call R equivalent. So R equivalent is your equivalent resistance, and that is also known as the total resistance of the circuit. R equivalent is a total resistance of the circuit, or the total resistance or the equivalent resistance. So total voltage is equal to total current into total resistance, that is equal to voltage across R1, that is the current across R1, into the resistance, that is the same Ohm's law. So Ohm's law helps us to find out the total resistance also. Plus what is V2? The same current same I flows through the R2 also, and into R2. So what remains common is, here the common factor is current is same in all the resistances, right? So current gets cancelled out. So what we get, the total resistance of the circuit is equal to R1 plus R2. Now this is an example when two resistances are connected in series. If there are n number of resistances connected in series, so let us generalize this concept. If there are n number of resistances connected in series, so let us say if n number, I do not know what is the number, 10, 50, 100, 1000, I don't know, it is not given. So if n number of resistors or resistances are connected in series, right? Video no to photo do. homework